Hey, continuing on with the lesson, if you look, I've changed things up a little bit. In this first fraction here, all I did was I took the square from here and moved it to there. But now what's happening different is that the denominator is growing faster than the numerator. So what's really happening in a fraction when the denominator grows faster than the numerator? Well, we start off with 10. So 10, you have 10 minus 2, which would be 8 over 100 plus 3 is 103, and you do your division there, and you get 8 divided by 103, and you get approximately 0.0777. Now, let's go on to f of 100. All right, well, again, the numerator is growing. It grows to be 98. But what's happening in the denominator is you get 1,003 or 10,000. 1,000. Yeah, 10,003. I wrote it right. I said it wrong. So we have 98 divided by 10,003, and that's approximately 0.0098. So what we see happening here, and it would continue if you don't necessarily trust this, you can keep going with yourself as far as this is concerned, and you would see, okay, this gets closer and closer and closer to 0. Likewise, if we did limit as x approached negative infinity, I'll drop down here. We'll get back to this problem in just a second. The limit as x approaches negative infinity for x minus 2 over x squared plus 3. And again, now we'll do f of negative 10 and then a number closer to negative infinity. Again, not very close, but let's just do negative 100. So negative 10 minus 2 would be negative 12. And negative 12 over, okay, this stays as 103. So 12 divided by 103 is negative 0.1165. And now to do that with negative 100, that would be negative 102 divided by, again, 10,003. And we get negative 0.0120. So what's happening in this case is that, yes, we're getting closer and closer to 0 again, but we're actually increasing to get closer because we're going from negative numbers. So we're basically approaching 0 from below the x-axis, where here we would be approaching 0 from above the x-axis. But still, in both cases, they are both approaching 0. Now, let's look at this final example, and we're going to try, instead of f of 10 and f of 100, I decided to go with f of 10 and f of 1,000 here. So again, 10 minus 2 is, as we had earlier, 8. And then it's over, okay, that would be 13. And 8 divided by 13 is approximately 0.6152. All right, let's just do f of 100. Okay, so f of 100 would be 98 over 103, which would be approximately 0.9515. And then last of all, let's do 1,000. So we would have 998 divided by 1,003. And we get approximately 0.995 0. So here, we're actually getting closer and closer to positive 1. So what we see happening here is we have something, in this case, it's getting closer and closer to positive 1. If you don't trust yourself, you can go further. You can try 1,000,000 or so forth, but you should see that you're getting closer and closer to positive 1 as the answer. But what we do here is they grow at a rate. The negative 2 and the positive 3 become less and less significant. In fact, they become less and less significant in all of the problems that we've looked at. So more specifically, though, in this case right here, they're going to grow to whatever the leading coefficients are, the ratio at least formed by the leading coefficient. So in this case, you have a 1 over 1, so it would be 1. If this had changed to be the limit as x approached infinity of 2x minus 2 over x plus 3. And again, let's see what f of 10 is, and let's see what f of 1,000 is. F of 10 would be 20. 20 minus 2 is 18. And then 10 plus 3 is 13. I'll go ahead and do this and then do this calculator in just a second. So now we have 2,000 minus 2, which would be 1,998. And then this would be over 1,003. If you look at these, maybe you see that they're getting closer and closer to 2. Now, this first problem doesn't really get close to 2. It's not even 1.5. It's 1.3846. But then 1998 divided by 1,003 is approximately 1.9920. So we're getting closer and closer in this case to 2. So we take the leading coefficient. If it had been x over 2x plus 3, it would be 1/2 instead of 2. So this is what's happening. So your rule here is basically, if the degree in the numerator is greater than the degree in the denominator, then the limit as x approaches infinity does not exist. It could be infinity or it could be negative infinity, but there is no bound to what the range value will be. In a case where, in this case, the degree in the denominator is greater than the degree in the numerator, your limit will be 0, because if the denominator of a fraction is getting bigger than the numerator, again, go from 1/2 to 2/4 to 3/10 to whatever. Both numerator and denominator are growing, but if the denominator is growing faster, the value gets closer and closer to 0. And then finally here, if the degrees are the same, if this had been x squared minus 2 over x squared plus 3, the answers would still be approaching 1. If this is 2x squared over x squared, you'd be getting closer and closer to 2. So anyway, we're going to look to the leading coefficients to solve these problems. In the next video, we'll look again at another graph problem, and then I will assign the homework.